Hey guys, hi, and once again welcome to the video. This video I'm gonna be answering a question on one of my YouTube videos that was how to essentially I made a video on one-to-one, one-to-many and many-to-many in Elasticsearch queries with the demo. On that video we essentially had a questions from Devidas, and she says, hi Somil, thank you for your videos which are interesting and very nice explanation. How to compare the performance of two different queries working on the same purpose, and what are the optimization ways to get better query results. So I'll try to answer this question today. So let me make this a little small. Okay. So first of all, thank you so much for your question, and I'll try my best to address this question briefly. So the first thing that you want to do is, if there are two queries which is serving the same purpose in Elasticsearch, how do we measure the performance? How do we make sure we optimize it, right? So I'll go very simple. The first way is you want to essentially go to Postman, take that query, okay, make a request. Do the same thing with the other query, make a request, and check the time in the Postman. How much time is it taking? Now you want to check that. Then what you want to do is you want to use a software called Apache JMeter. Essentially you want to create a test plan. You want to load the queries on one test plan with 100 users or 50 users at a second, that is 50 RPS, and the same thing with the other queries with 50 RPS. Then perform the JMeter test and then see, essentially grab the result, that is the average time, and then compare, okay, this query is taking this much time, this query it is taking this much time. Here we have not approached the optimization at this point. The next step, once you have information about how much time it takes, now let's talk about optimization, right? So the first thing that you want to do in Elasticsearch query, when you write a query, there is something called a source attribute, right? SOR. So that's essentially an array. So if you just need name and age, request only name and age instead of all the field. This will drastically improve your query, essentially query time. And I have done this in the past, and I can show you the results later on in some other videos. So only access the source, or only access the field that you require. That's a very important thing. The second optimization I'm about to suggest is essentially, after doing that, define a size attribute. So by default, Elasticsearch, I think it's 100 or 500, not sure, but if you just need 10 or 20 records, there's no need to ask for 500 or 1000 records. So set a size limit on the top of that. That's extremely important, and it will help you to essentially speed up your queries. Now the third thing that we can do essentially to speed the queries even further is essentially set node level and shard level cache. So setting up field level and node level cache will help you to have a boost in your performance. So which means if you're running the same queries, the next time it's gonna be cached, it's gonna be very, very fast. Okay, so these are optimization, right? So we could do all these tweaks and observe that. The fourth thing that I want to say, if you are performing aggregation with Elasticsearch, don't do aggregation and search in one queries. From my 3 years of experience working on ELK and maintaining a 2 terabyte cluster in the company, I'm saying from my personal experience, aggregation should go in a separate query, search should go in a separate query. They both should be running in a thread. Very important. Now, once you have done that, now there is not much optimization you can do on the query side. Now comes the shard and replicas. Now, depending upon if you have a lot of user to serve, which means if you have a lot of read requests to serve, you need to add replicas on Elasticsearch. Replicas essentially helps you to scale for better read-oriented applications, right? So if there are a lot of people reading, replicas will essentially help you, and it will also help you when essentially shard or node fails, right? So very important. After that, the most important, irrespective of whatever queries you write, is the shard. You need to have absolutely perfect number of shards. Incorrect number of shards are not going to work, and it's always going to give you problem. So essentially you want to make sure you start with a big number, and you can keep reducing the shards. Essentially I forgot, I did a video in the past where you could change the number of shards And remember, it is important because you could always do in a multiple. So for example, if I have 8, I can reduce it to 2, 4, 8, so on, right? So start with a number, and ideally you want to have up to 25 to 30 GB per shard as per recommendation and documentation. Then based on that, again, you want to make sure you are allocating, the cluster has optimum space, the cluster has optimum memory and RAM. So you want to, because think about it, if you have a 2 terabyte cluster and if you have 8 GB RAM, is it going to work? No, absolutely not. You're going to run into errors, which is why RAM is one of the most important. If you are using on AWS, it's important which instance to choose from. Should I use an M series or should I use a C series? C series are compute optimized. M series are memory optimized. How many data nodes do you need, right? So all these things will really help you to drastically improve your performance in Elasticsearch. I hope I have answered some of the question here, and I hope Devidas, this answer will help you essentially. Hopefully I've answered a couple of questions that you had, but if you have any other questions on Elasticsearch, I kindly request everybody to comment on the video, and if I see a very nice topic, I'll definitely reach out or comment or try to make a video as and when I get time. With that being said, thank you so much for watching. Keep smiling, keep programming. I'll see you guys in the next video.